This is a 1950 Crosley Hotshot.
When people think of racing legends, they imagine raw power, roaring engines, and machines built to dominate. But what if one of the most surprising competitors on the track barely had more power than a modern lawnmower? The 1950 Crosley Hotshot, with its modest 26 horsepower and just 3 gears, challenged every assumption about performance, speed, and what it really takes to win. Many laughed. Some doubted. Yet, underestimating this tiny contender became a costly mistake. Was it brilliance in simplicity or a complete fluke of engineering? One thing is certain, this unassuming car didn't just race. It disrupted expectations and forced the automotive world to rethink everything it thought it knew. The 26 horsepower Thunderbolt. New Year's Eve 1950 marked a pivotal moment in American motorsport history, though the setting bore little resemblance to the manicured circuits of Europe. The location was Hendricks Field in Sebring, Florida, a decommissioned World War II B-17 training base hastily repurposed into a racetrack. The concrete was rough and unforgiving. The Florida heat was rising, and the air was thick with the scent of high-octane aviation fuel and burnt rubber. This was the birth of the Sam Collier Memorial Grand Prix of Endurance, an event born from a fervent post-war desire to establish an American equivalent to the grueling 6-hour torture tests of Le Mans. The atmosphere on the grid was electric, bordering on chaotic. For the first time, American enthusiasts were attempting to replicate the endurance formula that defined European racing. Keep the car running, keep the wheels turning, and cover more ground than the competition before the clock ran out. To understand the sheer absurdity of the eventual outcome, one must first examine the formidable machinery that populated the starting grid. These were the undisputed kings of speed, representing the pinnacle of mid-century automotive philosophy. Dominating the paddock were the Italian masterpieces. The Ferrari 166 Barchetta stood as a testament to Enzo Ferrari's obsession with perfection. Powered by a screaming V12 engine producing 140 horsepower, it was sleek, sophisticated, and prohibitively expensive. It was designed to slice through the air with the precision of a scalpel. Beside the Italian contingent sat the British-American hybrids, the terrifying Cad Allards. These machines combined lightweight British chassis with massive, ground-shaking American Cadillac V8S, displacing 331 cubic inches or 5.4 liters. These engines churned out 160 horsepower and enough torque to pull a stump out of the ground. The prevailing wisdom of 1950 was brutal and simple. There was no replacement for displacement. Victory belonged to those who built the biggest engine, put it in the biggest car, and hammered the throttle until the competition broke. When these titans fired their engines, the ground shook. The Ferraris wailed while the Cad Allards thundered, creating a symphony of raw power that thrilled the spectators lining the hay bales and old runway markers. They had come to witness speed and dominance. Yet, tucked away between these leviathans of horsepower, sat a vehicle so small and unassuming that it looked more like a pit utility cart than a racing contender. It featured bug-eye headlights that seemed to stare in perpetual surprise, a body with no doors, and 10-inch wheels that appeared absurdly undersized. This was the 1950 Crosley Hotshot. The Hotshot was the brainchild of Powell Crosley Jr., a man who was not a racing legend but rather a tycoon of domestic convenience. He had made his fortune building radios and refrigerators, bringing affordable appliances to the average American family. He applied that same utilitarian logic to the automobile. He did not aim to build a Ferrari. He wanted to build a car for the masses. Cheap, cheerful, and capable of sipping fuel like a hummingbird. The result was a sports car that cost $925 brand new. For the drivers of the Ferraris and Jaguars, the Crosley specifications read like a punchline. Under its tiny hood sat a 44 cubic inch inline-4 engine, translating to a mere 0.7 liters. To put that in perspective, the Cadillac engine in the Allard next to it was nearly 8 times larger. The Crosley produced a total of 26.5 horsepower. It was equipped with a 3-speed manual transmission that lacked synchronization, coupled with an 85-inch wheelbase that made it look like a toy. When it rolled up to the starting line, the reaction from the crowd was not fear or respect, but laughter. The automotive press and the general public struggled to make sense of its presence. In the consumer market, the Crosley was frequently dismissed as a joke, with critics labeling it a minor hunk of junk. It was perceived as too small to be safe, too slow to provide excitement, and too strange to be desirable. To To the spectators at Sebring, seeing a Hotshot on the same track as a Cat Allard felt like watching a toddler step into the ring with a heavyweight boxer. It seemed destined to be a sacrificial lamb. The visual contrast was stark. The long, flowing lines of the Jaguar XK 120 AS and the muscular stance of the Allards overshadowed the tiny, doorless rectangle sitting on donuts. The prevailing wisdom suggested this car should not even finish the first lap, let alone compete. The straightaways at Sebring were long, former runways designed for bombers to take flight. A Ferrari could hit 120 miles per hour easily, while the Crosley would be lucky to break 70. However, the laughter masked a dangerous arrogance. The crowd, the competitors, and the critics focused entirely on the size of the engine, the price tag, and the appliance maker badge on the nose. They failed to notice the scale. They overlooked the fact that while the Cadillac weighed nearly 3,000 pounds, the Crosley, stripped for racing, weighed less than 1,000. They did not understand that in his quest for frugality, Powell Crosley had inadvertently stumbled into a realm of engineering purity that the big manufacturers ignored. They saw a 26 horsepower joke, not realizing they were looking at a loaded weapon. The Goliath of American horsepower was about to try and stomp on David, unaware that David had brought a calculator and a very strange strategy to the fight. The sun beat down on the concrete as the flag prepared to drop, and the biggest upset in American racing history sat quietly idling at 800 revolutions per minute, waiting to shock the world. Engineering the micro sports car. To understand how a vehicle costing less than $1,000 could challenge the aristocracy of European motorsport, one must look past the diminutive bodywork and analyze the physics of speed. The fundamental equation of racing is not simply horsepower, it is the power-to-weight ratio. A massive engine in a heavy chassis fights its own inertia in every corner and under every braking application. The Crosley Hotshot flipped this equation on its head. While the Ferraris and Cat Allards relied on brute force to overcome their mass, the Crosley relied on the absence of mass to maximize its limited power. The stock Hotshot weighed a mere 1,175 pounds. However, for the 6-hour endurance test at Sebring, the racing team put the car on a drastic diet. They stripped away the bumpers, removed the convertible top mechanism, and replaced the standard windshield with a tiny piece of aero glass. This aggressive reduction brought the curb weight down to under 1,000 pounds. When the mathematics were applied, the result was startling. A 26 horsepower engine pushing a 1,000 pound chassis created a power-to-weight dynamic that was far livelier than the raw numbers suggested. Every unit of horsepower in the Crosley had to move only a fraction of the weight that a horsepower in a Cadillac-powered Allard had to move. This allowed the car to maintain momentum through corners where heavier cars would be forced to brake hard and accelerate violently. At the heart of this featherweight chassis sat an engine that was a marvel of contradiction. Powell Crosley's reputation had been severely damaged by his previous engine design, the infamous Cobra, or copper-brazed engine. That earlier unit was constructed from stamped sheet metal brazed together, a novel idea that proved disastrous in practice, as it was prone to warping and catastrophic electrolysis holes. For the Hotshot, Crosley introduced the CIBA, or cast iron block assembly. This was a necessary evolution, replacing the stamped steel with a rigid, durable cast iron block that could withstand the thermal torture of racing. The CIBA engine was not just a fix, it was a technological leap. In 1950, most American engines, including the mighty V8S, utilized a flathead or pushrod design, which limited their ability to rev high and breathe efficiently. The tiny Crosley engine, however, featured an overhead camshaft design. An overhead cam setup allows for more precise valve timing and higher engine speeds, a feature typically reserved for high-end European sports cars or purebred racing machines. This 44 cubic inch, 724cc engine was a precision instrument disguised as an economy motor. It produced its peak power at 5,400 revolutions per minute, singing a high-pitched mechanical soprano compared to the low rumble of the V8S. Furthermore, the robust architecture of the CIBA block meant it could handle immense compression ratios, sometimes tuned as high as 14:1, allowing race mechanics to extract far more than the factory-rated output without blowing it apart. However, this sophisticated engine was bolted to a component that threatened to undo everything. The transmission was the car's undisputed Achilles heel. The Hotshot utilized a Warner 3-speed manual gearbox. This unit was a relic of cost-cutting, designed strictly for gentle street driving. Crucially, it was unsynchronized. In a synchronized transmission, brass rings match the speed of the gears before they engage, allowing for smooth shifting. In the Crosley's crash box, the driver had to perfectly match the engine revolutions to the road speed, a technique known as double clutching for every single shift. If the driver missed the timing by a fraction of a second, the gears would grind metal on metal. In a 6-hour race requiring thousands of shifts, the likelihood of the transmission shattering was nearly absolute. It was a glass jaw on a prize fighter. Yet, where the transmission was a liability, the braking system was a revolution. The Crosley Hotshot holds the distinction of being the first American production car to feature 4-wheel hydraulic disc brakes as standard equipment. This was the Goodyear Hawley system, adapted from aircraft technology. In 1950, virtually every other car on the grid, including the Ferraris, used drum brakes. Drum brakes work by pressing shoes outwardly against a spinning drum. Under the intense heat of racing, drums expand, causing the shoes to lose contact and the brakes to fade into uselessness. The Crosley's caliper-type disc brakes were immune to this thermal failure. The ventilated rotor design shed heat instantly, providing consistent bite-point braking lap after lap. While the system was imperfect for street use, it was notoriously susceptible to seizing up when exposed to road salt and mud, leading to a commercial disaster that cost the company millions. It was structurally perfect for the clean, high-speed environment of a racetrack. This technological advantage meant that while the heavy Ferraris had to start braking hundreds of feet before a corner to manage their heat, the Crosley driver could keep the throttle pinned until the very last second, scrubbing off speed with violent efficiency. This specific capability would become the cornerstone of the team's survival strategy, allowing them to protect the fragile transmission by relying entirely on the brakes to control the car's pace. The engineering profile of the Hotshot was a paradox: a race-ready engine and aircraft-grade brakes, handicapped by a transmission made of glass. The strategy of calculated subversion. To defeat the giants of international motorsport, the Crosley team did not rely on horsepower, aerodynamics, or financial backing. They relied on a paragraph in the rulebook that most spectators ignored. The inaugural Sebring race was governed by the Index of Performance, a French scoring system designed to democratize racing. In a standard race, the winner is simply the first car to cross the finish line. Under the Index of Performance, the winner is the car that exceeds its specific performance potential by the widest margin. The organizer, Alec Ullman, implemented this system to prevent the event from becoming a procession of the largest engines. The formula assigned a target distance and average speed to every car based on its engine displacement. This created a theoretical race that ran parallel to the physical one. The massive 5.4-liter engines of the Cat Allards and the high-revving V12S of the Ferraris were burdened with enormous expectation. To win the index, these powerful machines had to maintain a punishing average speed of nearly 67 miles per hour for 6 hours. They had to be nearly perfect, straining their components to the breaking point just to meet the baseline requirement. The Crosley Hotshot, with its tiny 0.7-liter engine, faced a completely different reality. The mathematical formula determined that a car of such modest displacement only needed to average 48.1 miles per hour to satisfy its handicap. This created a profound strategic inversion. The Ferraris were racing against the limits of physics. The Crosley was racing against a math equation. The team realized that reliability was mathematically superior to raw speed. If they could simply keep the car moving at a steady 50 miles per hour, they would generate a higher score than a Ferrari driving at 100 miles per hour that spent time in the pits changing tires or refueling. The human element behind this strategy was as impromptu as the car itself. The entry was not a factory-backed effort, but a last-minute arrangement put together by Victor Sharp, a local Crosley distributor. He loaned the vehicle to Ralph Deschamps and Fritz Koster, two spectators who happened to possess competition licenses. They were not professional racing drivers with a support crew. They were enthusiasts who understood the mechanical limitations of their machine. They knew that to exploit the index of performance, they had to finish the race. And to finish the race, they had to protect the car's weakest link. Deschamps and Koster analyzed the track and the car's fragile Warner 3-speed transmission. They concluded that the constant upshifting and downshifting required by the road course would pulverize the unsynchronized gearbox long before the 6-hour mark. The solution they devised was radical and counterintuitive. They decided to eliminate shifting almost entirely. The plan was to launch the car, gently work the gearbox into third gear, the top gear, and then leave it there for the duration of their stint. This decision fundamentally changed how the car had to be driven. By refusing to downshift for corners, the driver sacrificed all engine braking. In a normal race car, dropping a gear helps slow the vehicle and keeps the engine in its power band for a fast exit. The Crosley drivers voluntarily gave up this control. They committed to a style of momentum racing that bordered on insanity. They would carry as much speed as possible through the turns, knowing that if they slowed down too much, the little engine would bog down and struggle to accelerate back up to speed in high gear. To manage this delicate balance of momentum and deceleration, the drivers invented a technique that utilized the only surplus resource they had, their own bodies. They developed a system of human aerodynamics to assist the mechanical brakes. On the long, flat runways of Hendricks Field, the driver would hunch down low in the cockpit, tucking his head behind the small cowl to minimize wind resistance and squeeze every mile per hour out of the 26 horsepower engine. As the car approached a corner, instead of reaching for the gear lever, the driver would suddenly sit bolt upright. By exposing his chest and helmet to the slipstream, the driver acted as a human air brake. This sudden increase in drag helped scrub off speed without generating heat in the mechanical components. It was a crude physical form of active aerodynamics, decades before computer-controlled wings appeared on Formula One cars. This maneuver was only viable because of the Crosley's pioneering disc brakes. Since the engine was not helping to slow the car, the friction brakes had to handle 100% of the stopping load. If the car had been equipped with standard drum brakes, this strategy would have resulted in brake failure within the first hour. The disc brakes, however, could tolerate the abuse. The drivers could sit up, mash the brake pedal late, and rely on the calipers to bite consistently. The strategy was a masterclass in risk management. By stressing the robust brakes and the driver's abdominal muscles, they completely protected the fragile transmission. They turned the race into a test of efficiency, turning laps like a metronome, while the faster cars roared, pitted, and broke down around them. 6 hours of calculated momentum. At 3 p.m. on New Year's Eve, the starter's flag dropped, initiating the chaos of a traditional Le Mans-style start. Drivers sprinted across the track to their waiting machines, leaped into the cockpits, and fumbled for ignition switches. The roar that followed was deafening as the massive Cadillac V8S and the high-strung Ferrari V12S erupted into life, leaving thick clouds of tire smoke and exhaust in their wake. In the middle of this cacophony, the little Crosley Hotshot buzzed to life, sounding more like an angry sewing machine than a race car. As the field surged toward the first corner, the difference in acceleration was comical. The powerful Ferraris and Allards vanished into the distance, leaving the Crosley to trundle along at its own modest pace. To the casual observer, the race seemed over before it had arguably begun. However, as the adrenaline of the start faded and the race settled into a grueling rhythm, the brilliance of the Crosley strategy began to manifest. While the leaders were turning lap times that blistered the rough concrete of the old airfield, they were also consuming fuel and tires at an alarming rate. The heavy Cad Allards, wrestling with their own weight, hammered their suspensions over the expansion joints of the runways. Meanwhile, the hotshot drivers, Ralph Deschamps and Fritz Koster, were engaged in a discipline of absolute restraint. They adhered strictly to the non-shifting protocol. Driving the course in third gear for the entire duration required a counterintuitive rhythm. Entering a slow corner, the engine revolutions would drop dangerously low, threatening to stall or bog down. The driver had to resist the urge to downshift for power, instead carrying precarious amounts of momentum through the apex to keep the tiny engine in its power band. On the long straights, the engine would scream near its 5,400 revolutions per minute redline, the car vibrating intensely as it reached its top speed. The most bizarre spectacle for the marshals and spectators was the sight of the Crosley driver approaching a turn. Instead of hearing the engine blip for a downshift, they watched the driver suddenly pop up from behind the cowl, his chest hitting the wind like a sail. This human air brake, combined with the glowing disc brakes, scrubbed just enough speed to navigate the turn without touching the gear lever. As the sun began to dip and the shadows lengthened across Hendricks Field, the race turned into a war of attrition. The abrasive surface of the runways began to tear apart the tires of the heavier, faster cars. The Ferraris and Jaguars were forced to pit, their crews frantically changing wheels and pouring gallons of fuel into thirsty tanks. Every minute they spent stationary was a minute the Crosley spent moving. The Hotshot was a model of efficiency. It stopped only once during the entire 6-hour contest. The pit stop was a masterclass in minimalism. A quick swap of drivers, a splash of fuel, and a brief check of the lug nuts. Within moments, the car was back on track, its average speed hardly dented. Communication in 1950 was primitive, and the Crosley team had no radio link between the pits and the car. As the race entered its final hours, the tension in the Crosley pit grew. They were tracking the lap charts and calculating the index of performance in real time. They realized that while they were miles behind in physical distance, they were leading the mathematical race. However, the margin was razor thin, and a Ferrari 166 mm, driven by Jim Kimberly, was closing the gap. The team needed to signal their driver to push harder, but they had no pit board. In a moment of improvisation, a crew member grabbed a black suitcase and used a piece of white chalk to scrawl a frantic message. As the Hotshot buzzed past the pits, the crew member held the suitcase aloft. The message was simple and direct: speed up. The driver acknowledged the crude signal and leaned harder on the little machine. The final hour became a desperate run against the clock. The Crosley was averaging 52 miles per hour, well above its mandated target of 48.1, but the Ferrari was relentless. The sun had set, and the race finished in darkness, the track illuminated only by the headlights of the surviving cars. When the clock finally struck the 6-hour mark, the confusion at the finish line was palpable. Physically, the race was a blowout. The Ferrari 166 mm had completed 108 laps, covering roughly 403 miles. The Crosley had completed only 89 laps, totaling 332 miles. The Italian machine had finished 19 laps ahead, a distance of over 70 miles. To the crowd, the Ferrari was the clear victor. But in the timing booth, the officials were running the final calculations for the index of performance. They took the Crosley's actual distance and divided it by its required handicap distance. The resulting figure was 1.0854. The Crosley had exceeded its expectations by 8.54%. The Ferrari, despite its speed, could not match that efficiency percentage. The little roadster, which had been laughed at on the grid and described as a toy, had not just survived. It had conquered. It had turned 89 laps of the punishing airfield without a mechanical failure, utilizing a strategy that prioritized momentum over acceleration and reliability over power. As the engine silenced and the dust settled on New Year's Eve, the officials confirmed the impossible result. The 1950 Crosley Hotshot was the overall winner of the first Sebring endurance race. The triumph belonged not to the fastest car, but to the team that had best understood the rules and the limits of their own engineering. The triumph and the tragedy. When the final calculations were posted on the bulletin board at Hendricks Field, the result was so improbable that it seemed like a clerical error. The official index of performance score for the Crosley Hotshot was 1.0854. This specific number meant that the tiny roadster had exceeded its theoretical potential by a margin of 8.54%. In contrast, the mighty Ferrari 166 mm, despite finishing 19 laps ahead in raw distance, had failed to match that efficiency. The announcement sent a shockwave through the paddock. The spectators, who had spent the afternoon laughing at the toy-like car, now watched in disbelief as Ralph Deshawn and Fritz Koester were crowned the overall champions of the first international endurance race held on American soil. The trophy for the Sam Collier Memorial Grand Prix did not go to the Italian aristocracy or the British-American powerhouses. It went to a refrigerator manufacturer from Cincinnati, Ohio. This victory was not merely a fluke, it was a validation of a specific engineering philosophy. The race proved that the cast iron block assembly, the CIBA engine, was virtually indestructible when treated with respect. In the years following Sebring, this tiny 44 cubic inch power unit became a legend in its own right. It did not fade into obscurity, rather, it became the foundation for an entire generation of American grassroots racing. The Crosley engine became the de facto standard for the SCCA H-modified class, a category for small displacement sports racers. Throughout the 1950s, cars powered by Crosley engines dominated this class, winning 10 out of 12 West Coast races in one stretch. The engine's incredible power-to-weight ratio and its ability to withstand high compression tuning made it the darling of mechanics and tuners. It found its way into everything from homemade specials to dragsters. In one famous instance, a rail dragster powered by a modified Crosley engine achieved a top speed of 97 miles per hour, a staggering feat for a block that started life producing only 26 horsepower. The Sebring victory had proven that the heart of the Hotshot was a genuine piece of high-performance hardware, misunderstood by a market obsessed with size. However, the story of the Crosley Hotshot is not a fairy tale. It is a tragedy of timing and execution. While the car was winning trophies on the track, it was dying a slow death in the showroom. The very innovation that had secured the victory at Sebring, the four-wheel disc braking system, became the company's undoing in the real world. On the clean, dry concrete of an airfield racetrack, the caliper-type brakes were brilliant, shedding heat and providing consistent stopping power. But on the salted, muddy, and frozen roads of post-war America, they were a disaster. The Goodyear Hawley design used by Crosley was not sealed against the elements. When exposed to road salt and grime, the pistons would corrode and seize, causing the brakes to lock up or fail entirely. Dealers were flooded with angry customers facing tremendous service headaches. The reputation of the car, already fragile due to its small size and the previous failures of the stamped steel engine, crumbled completely. Crosley was forced to retrofit thousands of cars with old-fashioned drum brakes, a humiliating regression that signaled the end of their technological leadership. Furthermore, the American consumer of the early 1950s simply did not want a microsports car. This was the dawn of the jet age and the interstate highway system. The public craved chrome, tail fins, and massive V8 engines that floated over the road. A stripped-down 1,000-pound roadster that required a human air brake to drive effectively was an anomaly that the market could not digest. Powell Crosley Jr. had built a car for a future that hadn't arrived yet. He was trying to sell a Lotus or a Miata to a generation that wanted a Cadillac or a Buick. The financial losses were catastrophic. Despite the racing accolades, Crosley Motors was bleeding money. By 1952, just 2 years after the historic win at Sebring, the company collapsed. Powell Crosley Jr. lost an estimated $3 million on his automotive venture, eventually shutting down the assembly lines and selling his factory. The Hotshot, the champion of Sebring, became an orphan, relegated to the back pages of automotive history books. Yet, looking back through the lens of history, the victory at Sebring stands as a profound philosophical triumph. It remains the ultimate counter-argument to the brute force approach of motor racing. On that New Year's Eve in 1950, the racing world learned that speed is not a singular metric. The Crosley Hotshot proved that a lack of resources can be overcome by an abundance of strategy. It demonstrated that a 26-horsepower engine, when paired with a light enough chassis and a smart enough driver, can defeat a V12. The legacy of the Hotshot is the enduring lesson of the underdog. The Ferraris and Cat Allards were defeated not by a faster car, but by a better equation. They were beaten by a team that understood the rules better than the rule makers, and by drivers who were willing to turn their own bodies into aerodynamic devices to save a 3-speed transmission. Goliath didn't just lose to David, he lost to a math problem, a cast iron block, and the audacity of efficiency. The Crosley Hotshot remains the only car to ever shock the world by going 52 miles per hour. The 1950 Crosley Hotshot's victory at the inaugural Sebring Grand Prix remains one of motorsport's most fascinating paradoxes. While the consumer market ultimately rejected the tiny roadster for its quirks and fragility, the racetrack vindicated its engineering brilliance. By leveraging a radical strategy of non-shifting and human aerodynamics, the racing team utilized the car's advanced disc brakes and lightweight chassis to outmaneuver significantly more powerful competitors like Ferrari and Allard. This victory was not defined by raw speed, but by the intelligent application of the Index of Performance rules. Although Crosley Motors eventually succumbed to commercial failure, the Hotshot's legacy endures as a testament to efficiency. It demonstrated that in the face of overwhelming odds, a calculated blend of innovation and strategy can dethrone even the most formidable Goliaths of the racing world.